Okay, morning. So that hopefully you had good rest over the weekend. So how was last week? Good. Uh, Tired. Yeah, it's a new environment, and you were just out of the quarantine. So a lot of things that you still need to do. Um, in fact, for some of our incoming graduate students, they are still in quarantine, so they will join the classes uh, starting from the end of this month or even the beginning of next month. So it's also creating a lot of issues for us. Yeah, they had similar problem that you had during quarantine. That is Wi-Fi access. So even if we want them to join the class online, they could do it well, mostly asynchronous, meaning that we will have to record everything and for them to just watch by themselves. So another thing that I want to mention is because you are new to Taiwan and the environment, and I think the school and myself also concerned about your safety and whereabouts. So we do take your attendance so that we are aware that whether or not you attend classes for various reasons. One of them is we are not sure whether or not if you have any problems outside. I think most of you have already attended classes, but I understand that your class and civil engineering department class, there were in total 2 students who did not attend any classes last week. So if you are aware who is the person or who are the 2 people, maybe from our class or from the other class, I'm not sure. Whether or not the person has any reason or need any help. Okay? Just so that we are aware of what is going on. Otherwise, I think still please allow me to wear the mask. Maybe next week will be good. But you can still hear me well, right? Okay. So what I will continue to do, and hopefully going a little bit faster, and not going into too much detail. I think there will still be live sessions where you can ask questions and go into more detailed cases. Here in the class, I want to emphasize more on the concepts so that you understand what we are doing and why we are doing some key points. And during the live session is the opportunity to go through more detailed computation. So again, last week we had some introduction on these different kinds of cash flows. These are very structured, so it presents an opportunity for us to derive a very simple equation so that we can compute, to summarize the cash flow in some way. Remember earlier we were talking about time value of money. We try to make comparison of different cash flows. So we need to move the numbers to a specific time point so that we can make comparison. In most of the cases, it could be like this, meaning that it's not very structured. In that case, you just have to move them one by one. But with Excel, it's also quite straightforward. You don't need to compute individually. But if they have some structures, for example, this, meaning that all of them have total amount. So you can move that quickly by using an equation to the present time or to the future time. And it happens quite often, in fact. Happens quite often. A lot of payments are done in that way. Either you borrow money or you lend money to others. Usually, the return will be in equal installment over a period of time. And this one is having, as I said, the same amount of increment every period. And the reason that it started from this point, not from this point, we'll look at that. That we can also derive. You can imagine it's just a linear gradient series in high school. Arithmetics or mathematics have already taught us how to compute that. It happens, but not happens that often. Okay. But another one is geometric gradient series. For every instance, it is a multiplier of the previous one, that is 1 plus g. So this one will be this one times 1 plus g. So it becomes original value times 1 plus g squared. So we have this geometrically increasing series. It looks strange. Like, who will do this? But in fact, it happens quite often. If we are compounding, let's just say if you have salary raise every year, and every year if it increase by 2%, it will go up. Right? This is not related to our interest rate. This is about real numbers. Right? Your salary increased by 2%. So you look at your salary over the next 10 years, next 20 years, you will see the increase every year, 2% over the previous year. It could also be inflation. You know that in the society we have inflation. Buying products over different years, you need to spend different amount of money. Typically, we have inflation. Sometimes we have deflation. Oil price had a deflation over the past few years, but in general, it goes up. Right? Buying something this year costs 1, next year it costs 1.05. Recently in Taiwan, we also have some inflation on different products. So there could be a general inflation, there could be individual inflation. So you want to capture the changes of the prices. Sometimes we call them use those so-called consumer price index, which indicates how much money people spend to buy the same object. If you have studied economics a little bit in the past, you know that there's also something called purchase power. Right? For the same amount of money, your purchasing power will be getting lower. We're not talking about interest rate. We are just talking about you need to spend more money buying some product. In different countries, you have different prices. So all of them, the changes over time can be captured by this geometric series. Of course, these are actual numbers that we see. And when we want to compute their present value, we still need to consider the interest rate. We need to discount the value to the present time. So then, in that case, we'll have two rates. One is this growth rate, geometric gradient growth rate. The other is the interest rate. We'll compound them together. So one is getting higher, but when they are discounted back, they don't appear to be that big, that significant. If they are the same, you can imagine that if they are the same, this geometric gradient series, G equals the interest rate, you can imagine that they sort of cancel out. Right? Because when we take this value to the previous time, if we consider interest rate I, we'll discount I out of the amount. So here we see this value going up. If we want to compute the present value, we'll discount this value individually. Discount the value individually. So all of them will become equal again. We'll see that. Okay, most of them will be like this. Doing it by hands will be very painful, but doing it by Excel, I think it's relatively simple. So we have seen all these given present value find future value, given future value find present value using this notation, and we can look up from the table in the back of the textbook. Okay, so just follow the same principle. The simple case of present value, future value, equal value, or annual value, all of them can be converted directly, either through the equation or through the lookup tables in the back of the textbook. If you cannot find them, typically what we'll do is we do interpolation. If we don't have the interest rate for 8.75, we have interest rate for 8 and 9 or 8 and 10. We try to interpolate that value. Equal payment appeared a lot. We'll come back to this pretty soon. And all of these can be derived easily. I just cannot go through them. You can try by yourself. It's quite straightforward. Okay, linear gradient. And I think we mentioned about this already. So typically, it will look like this. We'll have the first payment. In the second payment, it will be increased by G. The third payment, it will be increased by G over the previous period. And in total, it will be 2G. So we have this series. We can compute it directly, or we can, but to simplify the computation, we'll divide this series into two. One is of the equal amount. The other is the increment. The increment will start from the second period, okay, so that it will match this part. So if you got a series like this, starting from this, you have to push it to the forward by one period. If you get a series with this G here, you want to compute, and using the equation we are going to introduce, after you do the computation, you need to put it forward, put it to the future for 2 periods, so that they give you the right solution. Okay. So divided by these two. For this, we have already know how to do it. For this, there's a equation. Again, there's a lookup table that you can find the parameters so that you can multiply. If it looks like this, reverse of this one, you may think that maybe I need to swap this so that it looks identical. But instead of doing that, in fact, we can take the largest value and make the payment equal. and subtract this amount, like G, 2G, 3G, 4G. This is what we are going to subtract from. So again, for this series, it's very easy to compute. For this, it's identical to this. Again, it starts from the first G starts from the second period, the end of the second period. And we'll compute this, either compute there. If we are computing for their present value, here we can compute the present value, and we subtract them or equal to the present value of this. Okay. And there's example. There are examples. And for geometric gradient series, basically it will still start from first period. You will have the first instance of the cash flow, and we always use this to distinguish from equal payment. Equal payment, we always use A. Here, either for a linear gradient or for a geometric gradient, we always put A sub 1, so that you know that we are not talking about something called equal payment. It's just the initial, the first payment. So we have A1. This is A1. A sub 1 times 1 plus G. It goes up like that. This one is just the opposite. It's minus G. It comes down like this. Okay. So it is A minus G, but you can also consider that as 1 plus minus G. Okay, meaning that G becomes negative. You can consider that. So here again, you can think of inflation. You can think of pay rates. You can think of anything that goes up geometrically or goes up year by year. And we can use the equation here. Unfortunately, in the back of the textbook, well, here we can also create a table, but now you see there's I, there's G, so there are two coefficients, two rates that we need to have. So the table will be quite limited, or the table will take a lot more pages. So I think most of the textbooks do not have a table for this. But if you want to find the table for this, you can still try to find. I think there are such table. But in any case, still, through a relatively simple derivation, we can come up with this equation. P equals to A sub 1 times those in the purple box. Okay. So this will be the above one will be used if I is not equal to G, because if I equal G, we'll have 0 here. Okay, from the equation we'll see that we'll have 0. Then we cannot compute. But as I said earlier, I stands for interest rate. And the increase of the number, if you want to find the present value, you will take the discount value back. Right? The discount value coming back is dividing by 1 plus I. So if 1 plus I equal to G, 1 is 1 plus G in the numerator, 1 plus I in the denominator, they are the same, so they cancel out. So basically, we'll all turn them back to A sub 1, and all the value come back to A sub 1. Then you take them one period earlier. So you divide it by 1 plus I. So when I is equal to G, you just need to plug in this equation. Okay. So again, you can just plug the number in. Do for yourself. The next part will be now we'll start to look at some of the more practical issues of engineering economics. One is something which happens a lot in the real life, and sometimes it's confusing and sometimes it's misleading. So it's about interest rate. Previously, we have already seen something called simple interest and compound interest. Right? Simple interest meaning that the interest will not be added into the principal and compute the interest. It seems to be simple, and it seems when we look at that, we say, okay, so simple interest doesn't seem to compound, so the effect may not be as big. That is from one aspect. Later we'll see one example. In fact, simple interest creates a bigger impact than compounding interest, depending on how you use it. In a lot of places, when we talk about interest rate, for sure we are talking about annual interest rate. Otherwise, it's very difficult to compare. Right? Monthly interest rate. Okay, if we want to say that, if we want to do that, we'll say that explicitly. Otherwise, when we say interest rate, usually we are referring to annual interest rate. And there are two kinds of interest rate here. One is called nominal, one is called effective. Effective is more like real interest rate you are paying. Nominal is just a value that we can reference. So when we say nominal interest rate, usually we need to specify how we will compound the interest. How we are going to compound interest. So if I have a nominal interest rate for credit card, 18% per year, that's not the effective interest rate, because for credit card, usually in the back, it will say compounded monthly, meaning that 18% will be divided by 12 months, which is 1.5% per month, and they will compound the monthly interest, meaning that every month they will charge you 1.0015%. You multiply by that. If you use your calculator to calculate, remember last time one of you told me that it's already 19 point some percent, 19.5, which is bigger than 18%. Okay, so when we say nominal, we need to know how it is compounded. Or when they just told you that, oh, it's APR rate, annual rate, when they did not emphasize that it is the effective rate, it is the nominal rate, and we need to divide it by number of compounding period, and use that interest compounding period to compute the true effective rate, annual effective rate. Compounding monthly is quite often. Sometimes it's compounded quarterly. Sometimes it could even be compounded weekly. If you are, there's a, I think there's a phrase, I'm not sure it's correct, but it's called loan shark. They lend you money, and they charge you interest rate daily. Then you can recompute. 18% becomes how much annually. Sometimes it's weekly, but when people have no way to borrow money, they will go to these loan sharks. Basically, people lending you money, but taking a very high risk because there's no place that you can get money, meaning that you are very desperate. Chances are you are taking a very high risk of borrowing money, so they are taking the risk, but the rate is too high, still too high, so they lend you money and say, okay, I'll pay back tomorrow. Then you couldn't do it. Oh, I'll pay back next week, next month. When it reaches next month, maybe it's already 50% more. You couldn't pay off. It's even harder for you to pay off. So you have to be very sensitive on the interest rate because the compounding effect is very significant. So this is how to make it more formal. This is the equation. We have effective interest rate, which is equal to 1 plus. This is the nominal rate. R is the nominal rate. Divided by number of compounding periods within a year. And to the nth order minus 1, which you can understand. It is exactly the same as I described. You have 18%. You have 12 compounding periods. So divided by 12. So you have 1.5%. 1 plus 1.5% to 12th order minus 1. That is your effective interest rate. Okay, if it's quarterly, then divided by 4, compounded by 4. So this is exactly what I said. It will be divided into 12 compounding period. Each compounding period is 1.5% interest rate. In total, it will be 19.56%. If you actually compound it monthly, 1 by 1, it will not be 18%. It will be 19.56%. Either way, it's quite high. 18% is very high. Credit card companies, basically they take 3% out of the processing fee already, not directly from us, but from the vendors. And maybe most of the people will return the amount that they spend, but if you miss just one time, it's already quite costly. They have penalty fee first, and they have, if you did not pay any or did not pay the minimum, you have the penalty first. Then they will charge you the interest per month, and based on different principles. So here it just shows that if you have a certain percentage, okay, let's still take 12. So if you compound it annually, it's still 12. If you compound it I think the number may not be correct. 12%, right, sorry. 12%, not 18%. 12% is still 12%. If you compound it monthly, it's 12.68. As a compounding period get more frequent, you can see that the rates get bigger. Okay. But you can also see that later we'll see see an equation, but as you can see that the difference gets smaller and smaller. So even if it's compounded infinite number of times, it will not go to infinity. It will converge to a certain point. Not much bigger than 12.74 if you are having nominal rate of 12%. Okay. But just remember that when it's compounded more frequent, then the interest rate is even higher. Okay. Another complication, which may or may not be that important, just so that you know, if people are presenting you with more complicated cases, you need to be able to compute. That is, we have payment periods. Previously, the previous equation, payment periods and compounding periods are the same. Right? So, if you have this interest rate compounding monthly, meaning that every month there will be this payment. So it's compounding monthly. But here, each payment period, well, within 1 year. Previously, it's 1 year. Now, the payment could be in 4 different or 4 equal installment, or 4 different installments, let's just say. 4 payment period. Okay. And each payment period will have a few compounding period. Right. Previously, we do this in 1 year. That's our effective rate. Now, if we do it every quarter, so every quarter we need to find out its effective rate. Of course, we can still compute the annual effective rate. Right? So here the equation is to help us to compute the effective rate, which is shorter or longer than 1 year, if that is our payment period. Okay. When we say effective rate, it's referring to the payment we will make at the time, and we want to know what exactly is the rate that we are paying. And here, in other cases, we may have payment period, which is not 1 year. It is 3 months, I just said. Okay, so when we want to compute the effective rate for 3 months, this is how it can be done. But there are also other ways. I mean, I think once you understand the basic principle, of course, you can do that directly. You may not even need to remember this equation. Just remember that if you have a let's just say nominal rate for 1 year, you know that it is compounded by month, so you'll compute the monthly effective rate. If the payment is every 3 months, then you just need to compound the 3 months effective rate. You will get the effective rate for 3 months for the quarter. It is exactly what this equation says. Okay, so you have 18%, and you have compounding period by months, and your payment period is quarterly. So each year there are 4 payment periods, and within each payment period there will be 3 months. So this is 12, and to the monthly compounding period. For each payment period, they have 3 months. Okay, 3. So 18% divided by 12 plus 1 to the third, or to the power of 3, meaning that we'll compound 3 months. Okay. Now, I think conceptually you understand that already. Adding a lot of statement, you need to remember that it's a little bit, to me, it's even more confusing. But just remember that we are usually given nominal rate for a year, and we can compute the smallest the compounding effective rate for the compounding period. So in this case, it could be just monthly compounding period, and the payment is if it's bigger than monthly, the payment is 3 months. It's quarterly, so 3 months. So you need to compute the effective interest rate for 3 months. So you just compound them 3 times, which is C, compounding 3 times. Then you'll get the effective interest rate for the payment period. That's why we are concerned with. Okay. Per payment period. So later they have maybe some complication, but basically what I said, the previous example is just like this. Here they are using 12%. So 12% nominal rate, and we have payment period is quarterly. So we have 4 payment period, and each payment period we have 3 compounding periods. Okay, so we can, since we know the effective rate for the compounding period is 1%. So if we want to know the effective interest rate for the payment period, per payment period, for the payment period, you can simply just compound them. You can get 3.03. Okay. Or you can come to here. If you want to know the annual interest rate, you can go into this 3.03 quarterly effective interest rate, compounded 4 times, or you can just do it straight, compounded 12 times. Both of them will give you 12.68, which is the effective interest rate, annual effective interest rate. As long as you know their relationship, there are many ways to come to the same results. Okay. So I mentioned just now that we said, okay, we can compound it semi-annually, we can compound it quarterly, we can compound it monthly, weekly, even daily. The number keeps growing. Well, if we compound it with infinite numbers of times and continuously, will the number explode? Will the number explode? Because the number keeps increasing. But if we look at the, maybe you can still recall your calculus. This is the equation that we had previously, right? So if we take the limit and take SC approach to infinity, and if you look at your calculus book, there's exactly one equation like this, and which can be represented this way. Okay, so rather than go to infinity, we'll have a constant, and to the r, over k minus 1. But you calculate this value, and you will find that it is for different k or different r and k, you will go to a value which is a little bit bigger than the compounding daily or compounding hourly. Hourly is already too much. I think hourly and compounded continuously will have very little difference already. Okay, so it doesn't go to infinity; it will converge symptotically to a value. Just for your information, sometimes people come up with this statement: "Oh, yeah, inventory costs should be accumulated continuously." How does that work? Sometimes you have this kind of notion of adding values continuously. If that happens, then just remember that it doesn't go to infinity. It just converge to a certain fixed value. And here is again, it just say the structure. Payment period. Previously, we say that it's quarterly, and compounding period is monthly. That we have already shown how to do it. But there could also be cases where your compounding period is longer than payment period. So that you can also compute using the same equation. Just that C will not be C, it will be 1 over C. Okay. Again, there are some derivation that you can come, and there are just different cases, example that you can check. Even more practical cases about credit card. We can go to the credit card case so that you know a little bit. So credit card, as I said, it's something a little bit tricky. If you don't know how they are charging you, and they have some marketing slogan, and there are some terminologies. Usually for credit card, I post some very useful, let's just say useful credit card. Annual fee could be, in Taiwan, it could be 30,000 NT dollars, which is quite expensive. And just imagine that if there are more function or service they provide, they'll charge you a higher annual fee. And there's a annual percentage rate. That is a nominal interest rate, APR. Usually is 18%. Again, effective annual rate is 19.56%. Okay, and there's a grace period, meaning that you spend the money, but they don't charge you, and they don't accrue the interest rate directly every month. Okay, after they conclude at a certain time, they give you a grace period, and you have to pay the amount before the end of the grace period. Okay, so you receive the bill, you don't have to pay it directly. If it's let's see, let's just say if it's the billing period is until 25th or 20th of this month. The grace period could be until 20 days from the billing, the closing period. And you'll receive your bill at maybe 25th, but the next month by the 10th, then you have to pay. If you don't pay, they'll charge you for the interest. Okay. If you don't pay any, they'll charge you some. If you don't pay the minimum payment, they'll penalize you, and you have to pay the interest. Let me just show you. There are different kinds of interest statement. One is so-called adjusted balance, meaning that you have paid off something, but hasn't reached the minimum amount. They'll charge you the remaining amount. It could be they'll based on the average daily balance. You will be owe a lot of money. You spend a lot of money at different time. They'll take the average based on the date and charge you for the interest for that amount. Or they'll just charge you off for the entire period if you don't pay it. Okay. So, or even if you paid it but not reaching that amount. Okay, so there are these details. If you look into your agreement, they'll tell you exactly how they charge you. And these, as you can see, there will be difference. Here is only 30. Here you are paying 45. Average is in the middle. But if they'll charge you the entire amount for the interest, it will be 35. If you just charge you for the amount that you haven't paid off, it's 30. So you can check on them and make comparison. So that's what I meant by there's a lot of there are a lot of details in the contract, and those details present differences which you may not know. Okay. Let's take a break. We'll continue on this part.